Hello there, and welcome back to Science for Sleep. Tonight, we are going to leave. Not far, not at first. We will begin where you are right now, in the room you are lying in the building that contains it, in the city or town or countryside around it. And then we are going to travel outward, slowly, gently, pausing at each new scale to let the mind adjust before moving on to the next. Because the universe does not reveal its true nature all at once. It requires patience. It requires the willingness to sit with numbers that mean nothing to everyday experience and let them slowly become something not understood exactly. The human mind was not built to understand scales this large, but felt, absorbed, allowed to settle into the background of consciousness, the way a sound absorbed over time becomes part of the quiet rather than an interruption of it. Tonight, we are going to travel from here to the edge of everything, from the ground beneath your body to the farthest reaches of the observable universe. And then we are going to come back. And when we do, the room around you will be exactly as you left it. Small, warm, quiet, and somehow, impossibly, more remarkable for having been placed in context. Tonight, where are you listening from? Is the sky outside your window dark? Are there stars above you right now, behind the cloud, or the light pollution, or the ceiling, waiting there as they always are? They always are. So let your body grow heavy. Let your breathing slow. Let the walls of the room expand gently into something much larger. And let's begin. The Earth is large by human standards. Its circumference at the equator is approximately 40,000 kilometers. If you could drive a car around the equator without stopping at highway speeds, it would take you more than 3 weeks. If you could walk it would take more than a year. And yet the Earth is not large by the standards of its immediate neighborhood. The Moon, the most familiar object in the night sky, orbits the Earth at an average distance of approximately 384,000 kilometers. This distance is so commonly cited that it has become almost meaningless. But consider it this way. If you could drive from the Earth to the Moon at highway speeds without stopping, the journey would take more than 5 months. If you placed all the other planets in the solar system between the Earth and the Moon, they would fit, with room to spare. The Moon is the only object beyond Earth that human beings have visited. 12 people have stood on its surface, all between 1969 and 1972. No human being has walked on the Moon in more than 50 years. The footprints left by the Apollo astronauts are still there. There is no wind on the Moon, no weather, no geological activity to disturb them. They will remain largely intact for millions of years. The Moon formed approximately 4.5 billion years ago, shortly after the formation of the Earth itself. The leading scientific hypothesis holds that a planet-sized body, approximately the size of Mars, collided with the early Earth in a cataclysmic impact. The collision vaporized much of both bodies. The resulting debris cloud, orbiting the young Earth, gradually coalesced under gravity into the Moon. The impact was so violent that it may have set the Earth's axial tilt, the 23.5-degree lean that gives us our seasons. The Moon is slowly moving away from the Earth. Tidal interactions between the Earth and the Moon caused the Moon to recede at a rate of approximately 3.8 centimeters per year. In the deep past, the Moon was much closer. 4 billion years ago, it may have been 10 times closer than it is today, looming enormous in the early sky. In the distant future, the total solar eclipses that occur when the moon's disk precisely covers the sun's disk will no longer be possible. We live in the geological eye blink during which the moon appears, from Earth, to be exactly the same angular size as the sun. This coincidence will not last. The sun is approximately 150 million kilometers from Earth. Light, the fastest thing in the universe, traveling at approximately 300,000 kilometers per second, takes about 8 minutes and 20 seconds to travel from the sun to the Earth. When you look at the sun, you are seeing it as it was 8 minutes ago. You are looking into the past. The sun is a star. This sentence is so familiar that its strangeness has been almost entirely erased. But the sun is a star, a sphere of hot plasma held together by its own gravity, generating energy through nuclear fusion in its core, converting approximately 600 million tons of hydrogen into helium every second. It has been doing this for approximately 4.5 billion years. It will continue for approximately another 5 billion years before exhausting its hydrogen fuel and expanding into a red giant.
The solar system extends far beyond the sun and the 8 planets. Its outer boundary, defined by the limits of the sun's gravitational influence, reaches perhaps 1 to 2 light years from the sun. Neptune, the farthest planet, orbits at 30 astronomical units from the sun. 1 astronomical unit is the Earth-Sun distance. Neptune is 30 times farther from the sun than we are. Mars is the most studied planet beyond Earth. It has been visited by more than 50 spacecraft. Its thin atmosphere, composed mostly of carbon dioxide, cannot support human life without technological assistance. But Mars was not always like this. Evidence from orbiting spacecraft and surface rovers indicates that liquid water once flowed on Mars. Ancient riverbeds, lake deposits, and mineral formations that only form in the presence of water have been identified across its surface. Mars was wet and possibly warm billions of years ago. Whether it ever harbored life is unknown. Jupiter is the largest planet in the solar system, containing more mass than all the other planets combined. Its famous Great Red Spot is a storm that has been observed continuously for at least 350 years. The storm is large enough to contain several Earth-sized planets within it. Despite its immense longevity, the Great Red Spot has been shrinking over the past century for reasons not yet fully understood. Jupiter has at least 95 known moons. The 4 largest, discovered by Galileo Galilei in 1610, are among the most scientifically fascinating objects in the solar system. Io, the innermost of the 4, is the most volcanically active body in the solar system. Its surface is covered in sulfur and silicate rock, constantly resurfaced by hundreds of active volcanoes driven by the immense tidal forces exerted by Jupiter's gravity. Europa, the second of Galileo's moons, is covered in a shell of ice beneath which a liquid water ocean is believed to exist, kept liquid by tidal heating. Beneath Europa's ice, the ocean may contain twice the volume of all the Earth's oceans combined. It is one of the places in the solar system most frequently cited as a candidate for extraterrestrial life. Saturn's rings are one of the most visually spectacular structures in the solar system. They extend up to 282,000 kilometers from Saturn's center, but are astonishingly thin, in some places only 10 meters thick. They are composed of billions of pieces of ice and rock, ranging from grains of sand to boulders several meters across. Despite their vast extent, if you compressed all the material in Saturn's rings into a single body, it would form a moon approximately 600 kilometers in diameter. The rings are not permanent. They are slowly being drawn into Saturn by gravity and are estimated to disappear in approximately 100 million years. Uranus rotates on its side. Its axial tilt is approximately 98 degrees, meaning that its poles take turns pointing almost directly at the Sun over its 84-year orbit. One hemisphere experiences approximately 42 years of continuous sunlight, followed by 42 years of continuous darkness. The cause of this extreme tilt is thought to be a massive collision with an Earth-sized object early in the solar system's history. Beyond Neptune lies the Kuiper Belt, a region of the solar system populated by thousands of icy bodies, including Pluto, Eris, Makemake, and Haumea. Beyond the Kuiper Belt lies the Oort cloud, a vast spherical shell of icy bodies extending perhaps a quarter of the way to the nearest star, the reservoir from which long-period comets originate when they are perturbed inward by gravitational interactions. Comets are among the oldest objects in the solar system, remnants of the material that formed the planets. Their icy nuclei contain water ice, carbon dioxide, ammono, methane, and organic compounds that have changed little since the formation of the solar system 4.5 billion years ago. Comets may have played a role in delivering water and organic molecules to the early Earth, contributing to the conditions that allowed life to emerge. Every atom in your body heavier than hydrogen and helium was made inside a star. Let that sit for a moment. The carbon in your cells, the oxygen in your blood, the calcium in your bones, the iron at the center of every hemoglobin molecule in every red blood cell in your body. None of these elements existed when the universe began. They were forged in the nuclear furnaces of stars that lived and died before the sun was born, scattered into space by stellar winds, supernova explosions, and eventually incorporated into the cloud of gas and dust from which the sun and the solar system formed. You are made of stardust. This is not a metaphor, it is nuclear physics. Stars form when clouds of gas and dust in interstellar space begin to collapse under their own gravity. As the cloud collapses, it heats up. When the temperature at the core reaches approximately 10 million degrees, nuclear fusion ignites. Hydrogen nuclei begin to fuse into helium, releasing energy. The outward pressure of this energy balances the inward pull of gravity. A star is born. The smallest stars are red dwarfs. They are dim, cool, and extraordinarily long-lived. A red dwarf with half the mass of the Sun will burn for approximately 50 to 60 billion years, roughly 5 times the current age of the universe. Red dwarfs are the most common type of star in the galaxy, comprising approximately 70 to 75% of all stars. The nearest star to the Sun, Proxima Centauri, is a red dwarf approximately 4.2 light-years away. The largest stars are the blue supergiants and hypergiants, objects so massive and luminous that they burn through their fuel in millions rather than billions of years. The star R136A1 in the Large Magellanic Cloud is estimated to have a mass of approximately 200 to 300 times the mass of the Sun, and a luminosity approximately 8 million times greater. When a massive star exhausts its fuel, the result is catastrophic. The core collapses in less than a second. The outer layers, suddenly unsupported, fall inward and then rebound in a shockwave that blows the star apart in a supernova explosion. For a brief period, a supernova can outshine an entire galaxy of hundreds of billions of stars. The explosion disperses the elements forged in the star's interior throughout the surrounding space, enriching the interstellar medium with the raw materials of future stars, planets, and living things. The remnant left behind depends on the mass of the original star. Stars of modest mass leave behind neutron stars, city-sized objects of extraordinary density. A neutron star with a mass twice that of the Sun is compressed into a sphere approximately 20 kilometers in diameter. A teaspoon of neutron star material would weigh approximately 10 million tons on Earth. Neutron stars rotate rapidly, sometimes hundreds of times per second, and can emit beams of radiation that sweep through space like lighthouse beams. When these beams sweep across the Earth, they are detected as regular pulses of radio waves. These objects are called pulsars. The Sun is one of approximately 2 to 400 billion stars in the Milky Way galaxy. 2 to 400 billion. If you counted one star per second without stopping, it would take more than 6,000 years to count all the stars in the Milky Way. And the Milky Way is one galaxy among hundreds of billions in the observable universe. The Milky Way is a barred spiral galaxy, approximately 100,000 light-years across. A light-year is the distance light travels in 1 year, approximately 9.5 trillion kilometers. The Sun is located approximately 26,000 light-years from the center of the Milky Way, roughly halfway between the center and the outer edge of the disk. It orbits the galactic center at a speed of approximately 240 kilometers per second, completing one orbit approximately every 220 to 250 million years. In the approximately 4.5 billion years since the Sun formed, it has completed approximately 18 to 20 orbits of the galaxy. The Milky Way is not a static, isolated structure. It has absorbed smaller satellite galaxies over its history and shows evidence of these past mergers in the distribution of stars in its halo. And in approximately 4.5 billion years, the Milky Way will collide with the Andromeda galaxy. Andromeda is the nearest large galaxy to the Milky Way, located approximately 2.5 million light-years away. It is the most distant object visible to the naked eye from Earth. Despite being 2.5 million light-years distant, Andromeda is approaching the Milky Way at approximately 110 kilometers per second, drawn by the mutual gravitational attraction between the two galaxies. The collision will be dramatic by astronomical standards and entirely unremarkable by human ones. The vast majority of the space within a galaxy is empty. Direct stellar collisions are extraordinarily unlikely during a galactic merger. What will happen instead is that the two galaxies' gravitational fields will interact, disrupting the orbits of billions of stars, drawing out long streamers of stars into intergalactic space, and eventually merging into a single, larger galaxy. Beyond the Milky Way lies the Local Group, a collection of approximately 80 galaxies bound together by gravity. Beyond the Local Group lies the Virgo supercluster. Beyond that, the Laniakea supercluster, identified in 2014, contains approximately 100,000 galaxies and spans 500 million light-years. It is one of the largest known structures in the universe. At even larger scales, the universe is structured like a cosmic web. Vast filaments of dark matter and ordinary matter connect galaxy clusters, which sit at the intersections like pearls on a net. Between the filaments lie enormous voids, regions of space hundreds of millions of light-years across that contain almost no galaxies. The largest known void, the Bootes void, is approximately 330 million light-years in diameter. The observable universe extends approximately 46 billion light-years in every direction from Earth. The Big Bang, the event that initiated the universe as we understand it, occurred approximately 13.8 billion years ago. It was not an explosion in space. It was an expansion of space itself. As the universe expanded, it cooled. Quarks and gluons condensed into protons and neutrons. Protons and neutrons combined into atomic nuclei. Hundreds of thousands of years later, electrons combined with nuclei to form neutral atoms. The universe became transparent to light for the first time. The light released at this moment has been traveling through the universe ever since, redshifted by the expansion of space into the microwave portion of the spectrum. It is now detectable everywhere in the sky as the cosmic microwave background radiation, a faint glow of ancient light that encodes the conditions of the universe when it was 380,000 years old. The cosmic microwave background was first accidentally detected in 1965 by Arno Penzias and Robert Wilson, two radio astronomers who were trying to eliminate what they thought was noise from their antenna. The signal was the oldest light in the universe. They won the Nobel Prize in Physics in 1978. Dark matter is a form of matter that does not interact with the electromagnetic force, meaning it does not absorb, reflect, or emit light. It is therefore invisible to all our telescopes. We infer its existence from its gravitational effects. Approximately 27% of the universe consists of dark matter. Its nature is unknown. Even more mysterious is dark energy. In 1998, two independent teams of astronomers studying distant supernovae discovered that the expansion of the universe is accelerating. Something is pushing the fabric of space apart at an increasing rate. This something is called dark energy. It constitutes approximately 68% of the total energy content of the universe. The nature of dark energy is entirely unknown. For most of human history, we did not know whether other stars had planets. The first confirmed detection of a planet orbiting another star came in 1992. In 1995, Michel Mayor and Didier Queloz detected the first exoplanet orbiting a Sun-like star. They received the Nobel Prize in Physics in 2019. Since then, the count of confirmed exoplanets has grown to more than 5,500. They range from scorching hot Jupiters orbiting so close to their stars that a year lasts only days, to rocky worlds in the habitable zones of their stars where liquid water might exist on the surface. The Kepler Space Telescope, launched in 2009 and retired in 2018, detected more than 2,500 confirmed exoplanets and suggested that planets are not rare exceptions, but universal features of stars. Statistical analysis of Kepler's data suggests that virtually every star in the galaxy has at least one planet. The nearest potentially habitable exoplanet to Earth is Proxima Centauri b, a world orbiting in the habitable zone of Proxima Centauri, the nearest star to the Sun at 4.2 light-years. Whether Proxima Centauri b is habitable, and whether it has an atmosphere at all, is unknown. The TRAPPIST-1 system, approximately 40 light-years from Earth, contains 7 rocky planets, 3 of which orbit within the habitable zone of their red dwarf star. The James Webb Space Telescope, launched in 2021, has been studying the atmospheres of the TRAPPIST-1 planets in detail. The universe contains approximately 2 trillion galaxies in the observable volume. Each galaxy contains hundreds of billions of stars. A significant fraction of those stars have planets. The habitable zones of those stars contain an unknown but potentially enormous number of rocky worlds with conditions that might permit liquid water. Given these numbers, it is difficult to argue that life could not have arisen elsewhere in the universe. The basic building blocks of biology, amino acids and nucleotides, have been found in meteorites and detected in interstellar space. The conditions that allowed life to emerge on Earth appear to be far from unique. And yet, we have found no evidence of life anywhere beyond Earth. The silence of the cosmos, the absence of any detected signal despite decades of searching, is sometimes called the Fermi Paradox. If life is common, where is everyone? The possibilities range from the sobering to the hopeful. Perhaps life is common, but intelligent life is rare. Perhaps civilizations inevitably destroy themselves before they can communicate across interstellar distances. Or perhaps, and this possibility is one that the mathematics of the universe does not rule out, we are among the first. The Earth formed 4.5 billion years ago, early in the universe's history of planet formation. We may be early arrivals in a universe that will be generating life and intelligence for trillions of years to come. Those were 100 space facts to fall asleep to, and now the journey reverses, gently, unhurriedly. The 2 trillion galaxies of the observable universe recede, becoming a vast and luminous fog. The Milky Way resolves from a smear of ancient starlight into one galaxy among billions. And there, orbiting at a distance of 8 light minutes, the third rock from the star, small and blue, and wrapped in a thin film of atmosphere and ocean. And inside that atmosphere, in a room somewhere on the surface of that rock, a body is growing heavier. A mind is growing quieter. The breath is slowing to a rate that has nothing to do with the scale of the universe, and everything to do with what it means to be a living thing at the end of a day. You are made of atoms forged in stars. The oxygen you are breathing was made in the cores of massive stars that exploded before the sun was born. The iron in your blood was produced in a supernova. You are the universe made briefly aware of itself, lying in a small room at the end of a small day, on a small rock, orbiting one star of 400 billion in one galaxy of 2 trillion. And somehow, improbably, wonderfully, you are here. The stars are still out there, behind the ceiling and the clouds and the light-polluted sky. The same stars that human beings have watched from the beginning. The same universe that was there before you arrived and will be there long after you leave. But tonight, it is enough to be here, in the small, warm room, in the small, warm body, at the end of a day in one life, on one world. Let your eyes grow heavy. Let the scale of everything settle into something like peace. Science for Sleep will be here when you return.